Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform, where you are preparing for your aspired examinations, that is the GATE and the PSC. So I welcome you all to this session, and before starting this session, let me give a brief introduction about myself. My name is Vidyapati Kumar, and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and I'm the author and co-author of various research papers publication of national and international journal. You can follow me at unacademy.com at the rate of v.ksir, where I am teaching the full strength of material that is totally free. So you can check out those videos, and definitely you can follow me here. Whenever I will be posting a new videos, you will be getting notified at the same time. So basically, in this, we have started the series of non-traditional machine processes, and I will explain to you what is the meaning of the non-traditional processes. That is in other words, it is that is also known as non-conventional machining processes or the unconventional machining processes. So this is the one of the non-conventional processes that we are going to deal here. That is the electrochemical machining, which is shortly known as ECM. Now, see, before starting the topic, you have seen that I have separated that electrochemical. So, electro and the chemical. So, basically, in this ACM, we are using the electric energy as well as the chemical energy. Both the energies are there in this machining processes. So we are going to see these things in a very great details in the subsequent slides only. But before moving into that, if you have not downloaded the Unacademy Learning app, download the Unacademy Learning app, as it is totally free of cost. In this, actually, there is a free section. There is a free section in which I teaches the free classes. That is the special class. That is the special class, and you can watch the special class of me. That is the teaching the strength of material each and every day at 10 a.m. As well as there is a paid section there. That is the paid section. That means that after enrolling into some of the courses, that is the plus subscription or the iconic subscription, definitely then you are watching these paid classes. But before that, these are the free classes. You can go and check out those things. So what are the benefit of this Unacademy Learning app? Daily life classes would be there. Courses are very much structured in nature. Tests and quizzes you will be given, as well as unlimited access of the course content materials are there. And if you have not downloaded the if you have not like subscribed the plus subscription, if you have not taken the plus subscription, do it, as it is totally worth it. Means it is totally worth it. That is the 100% syllabus would be covered. 100% syllabus would be covered, as well as since this is a very high time that you have only 2.5 or 3 months in your hand, definitely you can go for the 2 months or the 3 months plan. And the benefits are like what: daily life classes are there, courses are structured in manner, test and quizzes you can give, and the unlimited access of the course materials are there. That means here the courses are designed in a very special way, in a chronological order, so that it is beneficial for. Also also there is another subscription, that is the iconic subscription. So basically in this iconic, you are getting everything. That means whatever the benefits that you are getting in the plus, you are also getting these benefits in this iconic. Apart from that, you are getting the one another benefit, that is known as the personal coach. So what is this personal coach? Basically, you can choose any of your educator to be your personal coach, and that educator is liable to help you throughout the preparation of the gate and ES. Apart from that, that educator will also track your study. What I mean from that is, suppose you are giving some examinations, that is the mock test or the practice test. So basically your practice set or the mock test results will be analyzed properly, that where exactly you are committing the mistakes. So based upon that, the personalized analysis would be given to you, and that would really be helpful for your boosting the performance in your gate examinations. Apart from that, question and answer would be given for you to you for the practices purposes. For example, the mock test would be there, for the practice papers would be there. So there are a lot of number of questions that are given to you for the practice only, so that you may not have to refer any other source or the content materials for the practice purposes. So basically, you are getting these benefits you are getting in the plus subscription, as well as in the iconic subscription you are getting these benefits as the plus, as well as these are the extra benefits that I have talked about. That is the personalized test analysis will be the preparatory study materials, that is the PDF, and the other source content materials will be given to you as per the need. Now, these are the top educators of the Unacademy. You can learn definitely with the top educators of the Unacademy also by enrolling in any of the courses. And for the GATE and ESE, there are a lot of batches which has already been started for mechanical, civil, electrical, electronics, production, industrial, so on and so forth. But definitely you can go and check out those batches. So there are a lot of batches like rank booster batches are there for the EC, for the electrical, for the mechanical EC prelims batches are there. So for the batch B, batch a lot of batches has already been started. And suppose that this is a gate preparation, 90 days are there. ESC prelims for EC, for mechanical, rapid revision batches are there. Okay, rank improvement batches are also there, doubt clearing batches are also there. So there are a lot of batches which has already been started in the month of October and in the month of November. So you can definitely go and check out these batches, and if you want to enroll in these batches by using my code SIRVK for the maximum discount. Now, if you are going for the plus subscription, if you are going to subscribe for the with the plus subscription, definitely you can. If those who are in preparation for the Gate 2021, they can definitely go for the 1 month or a 3 months plan, and that will be definitely be beneficial for you. And those who are in second year or third year, definitely they can go and check out these 18 months and 24 months plan, so that that will be beneficial for you. And based upon your easiness, you can always go and check out these plans. And whenever you are going to subscribe, use my code SIRVK to get a 10% off, as well as you will be automatically subscribing to my personalized mentorship program. And suppose that if you are going for a 12 months plan, that will be costing around 30,250, but you will be using my code SIRVK, then that discounted amount would be 27,225. Similarly, for the iconic subscription, if you are going for the iconic subscription, these are the prices. And definitely for suppose that you are going to subscribe with the iconic subscription, use my code SIRVK to get a 10% off. So let's start our discussion for the electrochemical machining processes. So what is the electrochemical machining process? This is the first and foremost thing that comes in our mind after hearing this word. So basically what you can see from here, there is an electro, is the electrical energy is associated with it, and there is a chemical. So basically both of the thing is actually responsible for the electrochemical machining process. And how the machining is going on, so we are going to analyze the basically the machining processes that is going to be happen in this entire session. But before that, first and foremost thing, if you have heard about the electroplating, I am pretty much sure that you have heard in your chemistry classes. But if you have not heard, then don't worry about it. Basically, this ECM process, that is the electrochemical machining process, this ECM process is known as the reverse of the electroplating process. Let me write it here. So ECM process is known as reverse of electroplating process. Now, what is an electroplating? So basically, just to understand, suppose there is a container. Okay, suppose there is a container, and in this container, you have filled this container with some electrolytes. Now, what is this electrolyte? What is this electrolyte? So basically, electrolyte at this point of time, understand that electrolyte is a fluid which conducts the electricity. Yeah. So electrolyte is a fluid which conducts the electricity. Now, basically, in this electroplating, what we do, we put the two electrodes. Fine. So two electrodes are there. Now, these two electrodes are connected with the power source. So suppose there is a battery. So basically, there is a power source, and you have connected this with the power source, and after that the processes takes place. So let's try to understand this. So what I have told you, this is an electrolyte, and there is a two electrodes. So first electrode is this, and the second electrode is this. Now you can see here there is a battery which is connected, that is the power source. Now positive terminal of the power source is connected with the electrode, that is known as anode, as well as the negative terminal of the power source that is connected with the electrode, that is known as cathode. And this electrolyte, so whenever you have just closed the circuit, so electrolyte will conduct the electricity. Fine, this is what is the basic phenomena we have seen. Now what is happening, so see, you cannot choose any of the electrolytes or any of the anode or cathode. So basically, suppose that if you want to deposit the copper, if you want to deposit the copper suppose if you want to deposit the copper on the cathode, just you have seen that some of the ornaments or the jewelry, in the ornaments and in the jewelry, we give the, मीन्स लाइक द सरफेस इज इलेक्ट्रोप्लेटेड, है ना। कभी कभी हम बोलते हैं, जब हम देखते हैं कि सोनार के पास हम जाते हैं और सोनार बोलता है अरे ये तो चांदी के ऊपर सोना चढ़ाया हुआ है, मतलब क्या, इलेक्ट्रोप्लेटिंग इज, दिस इज द प्रोसेस, राइट, दैट इज we are plating the material with some other materials, right? So if you want to, suppose if you want to plate this material with the copper, okay, so definitely the anode that you will be taking will be the copper. Fine. Now also this electrolyte should be of the copper based electrolyte should be there. This is the one of the criteria, that's what I wanted to tell you. Suppose that you want to means like electroplate any of the material with the copper, so definitely the electrode that you will be taking, that should be copper, as well as the electrolyte as well as the electrolyte should be copper based solution. Suppose that the copper sulfate you want to take it, fine, so copper sulfate is a copper based solution. Now let's try to understand this. So suppose there is a copper anode, we have taken a copper anode, and this is a brass anode. So my basic intention is what, to to basic intention is to coat this brass with copper, isn't it? So that's why we have put this copper electrode. Now what is happening, you have just dipped down, there is an electrolyte, and this electrolyte is actually copper based solutions. So basically this is a copper sulfate, right? Basically this is a copper sulfate. Now see here, so this is this is a electrolyte, and this is a copper sulfate solution. So definitely in this electrolyte the copper will be getting separated, and this is the sulfate. Fine. Now we have seen that this is a positive charge terminal, and this is a negative charge terminal. So definitely due to this will be negatively charged, and this will be positively charged, correct? Now see here, now this is the copper particle. Now this Cu2 plus will be attracted towards this brass cathode. Why? Because this is a negatively charged and this is positively charged. And similarly, this negatively sulfate particle will be getting to this copper anode. Fine, that's what is seen in this figure. So basically the copper particles will be attracted towards this negative terminal. Now see here, after that what is happening, after that what is happening, you can see here that since there is a negative, since it is a negatively charged, so definitely a negative ions, so definitely negative ions will be actually flowing from this side, and the negative ions will be flowing. Now what is happening, there is a process which is called as reduction is going to happen. What is this reduction? See here, so earlier we will be having Cu, so we know that Cu2 plus is having, right? So that is a Cu plus plus. Now it is gaining the two electrons, that is the, since there is a flow of electrons from this part, so definitely the electron will be there. So what we can see from this reaction, that is the Cu double plus plus two electrons that it is gaining, and after gaining this electron it is reduced to the copper. Fine, that is the Cu. Now see, after that, suppose that after that what is happening, so suppose this is again, this is connected with the positive terminal. Fine, this is connected with the positive terminal, and since this is connected with the positive terminal, so what is happening, the positive ions will be getting a here, right? So basically from here, this is the copper, this is the copper anode. Fine, so copper anode will be separated as Cu2 plus, Cu2 plus, and this from the electrolyte SO4 will come to here, and when there will be a reaction into them, उनके बीच में रिएक्शन होगा, और उस रिएक्शन के कारण क्या होगा हमारा Cu, see this is the copper anode, so Cu will be broken down into Cu plus plus, and the two electrons will be released. Fine, so what we can see, when the electrons will be released, when the electrons will be released, then the oxidation process will be happening. Now what is happening due to this oxidation process, basically try to understand that. See here, copper particles is getting, means like, this is the brass particle, and copper particle is taking the place of it, है ना? जो ब्रास है उसके ऊपर में कॉपर का पार्टिकल्स वहां पर सेटल कर रहा है, तो कॉपर का प्लेटिंग होना स्टार्ट हो गया, है ना? देख रहे हैं आप यहाँ पर कलर्स हैज ऑलरेडी बीन चेंज, so there is a copper plating which has already been started. Now see, since there is an loss of the electrons from here, since the electrons are losing from here, so definitely from here you will be seeing that some of the part of the copper will be reduced. Just see here, since there is an oxidation which is happening, since there is an oxidation which is happening, so definitely the copper will be start loosening its shape, and hence these copper particles will be means like settling down in this brass cathode, and entire brass will be electroplated with the copper. And this is how we see the electroplating process. This is what is the basic electroplating process. And what we have seen, what we are going to see in the ECM process, ECM is just reverse of the electroplating process. So so what we have seen all in all in this electroplating process is that there is a loss of electrons. So basically from here the electrons will be losing, right? So electrons will be losing, so when the electrons will be losing, so this anode will be what, एनोड क्या होगा, एनोड टूटेगा, राइट? तो एनोड जो होगा कॉपर का पार्टिकल्स वो टूटेगा, तो कॉपर की पार्टिकल्स टूट के कहाँ जाएगी, डेफिनेटली दे आर कंसंट्रेटिंग ऑन द कैथोड. Fine, that is known as reduction process. So basically this is the gain of electrons is happening here, so electrons will be gaining here, and the lose of electrons are there in this oxidation process. So basically this is all about the electroplating process. Now we have seen that the electrolyte is used in these processes. So what exactly is this electrolyte? So basically the electrolyte is so chosen that the anode, so basically the anode is the workpiece, is dissolved but no deposition takes place on the cathode. And these are the properties that should be of the electrolyte, and definitely we are going to see these properties in a great detail just a bit. But first of all, try to understand what is happening in this process of electrochemical machining. See here, suppose Suppose this is a workpiece. Suppose this is a workpiece and you have a tool. Suppose this tool is like this. So this is a tool, fine. And this entire part, suppose this entire thing is in between the electrolyte, fine. This is in between the electrolyte, fine. So this is my tool, this is my tool, and this is the electrolyte, fine. Now what will be happening here, just to try to understand here, that this tool will move down, fine. This tool will move down, and when this tool will move down, what is happening, you can understand. Let me connect this tool with the negative negatively charged, and let this workpiece is connected with the positive terminal of the power source, fine. So what is happening, since this is connected with the negative particles, so electrons will be bombarding, fine. So suppose the electrons are here, suppose the electrons are here, so it will get bombarded here on the workpieces, fine. So whenever it is getting in the workpieces, what is happening is there is a material that is going to be removed, the material that is going to be removed from this workpiece, fine. So basically, let me draw the another figure, what is happening after that. So basically this is your tool, fine. This is your tool, this is your tool, and this is your workpiece, fine. So what is happening, basically, you have seen that the material is removed, how the material is removed from the means like how the electroplating is done, right? So plating मतलब कि किसी के ऊपर चढ़ना, मतलब वो पानी चढ़ाने वाला केस आप सोच लें, तो that is happening. Now basically in this what is happening, यहाँ पर चढ़ा नहीं रहे हैं, यहाँ पर आप रिमूव कर रहे हैं. You are not plating something, you are actually removing it. So basically the metal removal is actually due to the reverse of the electroplating. And suppose these kind of the shape that you want to make in this workpiece, so definitely you can, what you will do, you will just put it down, है ना? You will move it, move the tool down, and definitely the whatever the shape is there, that shape will be replicated in the workpiece, fine. Now this is what is happening in the entire process. Now I'm pretty much sure that you may not have understood these things, and if you have not understood these things, don't worry about it. Definitely we are going to see this in a just a while. Suppose that, let me draw the ECM process. So basically what is happening, a schematic diagram that I'm going to make here is, so suppose there is a tool, fine, there is a tool. So there is a tool like this. Now in this tool, what is happening, you are flowing the electrolyte from here, fine. So there is this is a tool like this, this is a tool like this, and from this tool, what is doing, you are just, this is a tool, and what you are doing here, you are just flowing the electrolyte from here, fine. So so from here the electrolyte will flow, the electrolyte will flow here, the electrolyte will flow from here. Now there is a workpiece, there is a workpiece like this. So this is a workpiece. Now try to understand that you have connected this tool with the negative terminal. Fine, that is, suppose you have connected this tool and the workpiece with the power supply, isn't it? So there is a power supply, and you are connecting this with the, this is a negative terminal and this is a positive terminal. Fine. So basically this tool will be negatively charged. Now see here, I have told you that what we want to move, right? So see here, just a bit here, I have explained you that what I am doing, I'm just moving this tool in the downward direction, isn't it? So basically how you can move the tool, so there is a controlled movement of the tool is actually done by the servo mechanism. Fine. So here is a servo motor which is fed. So here there is a servo mechanism like this. Fine. So here is a servo mechanism. So basically there is a servo mechanism, and with this servo mechanism there is a servo motor which is attached to it. So due to this, what is happening, a constant feed is getting down. Fine. So a constant feed, or a constant feed of the tool, right? So constant tool feed is getting down. Fine. So this is your workpiece, right? Now what I have told you that, there is an electrolyte, right? So basically here the electrolyte is flowing, and you are actually pumping this electrolyte from a storage tank. Yeah. So there is a storage tank like this. Suppose there is a storage tank like this. Okay. So there is a storage tank like this. Now what you are doing here, basically you are pumping this electrolyte. There is an electrolyte which is filled here, and what you are doing, you, with the help of the pump, suppose here the pump is attached. So here the pump is attached, and with the help of the pump, what you are doing here, this electrolyte is flowed. Electrolyte will flow, and it will be getting here. Fine. So here all the spaces will be taken by the electrolyte. Clear? Fine. So I hope you are understanding these things. Now this entire machining thing is kept in a chamber. So this is a chamber. Clear? So this is a chamber in which this entire setup is put down. So I hope you are understanding. Let me level these things. This is a tool, this is a workpiece, this is a chamber. Clear? This is your electrolyte. This is your electrolyte. Now see here what is happening. Try to understand that this is your tool. Suppose this is your tool and this is your workpiece. So you are moving this tool down, 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 and down, and again that whatever the means like the shape of the tool will be there, the exact shape will be replicated in the here in the on the workpiece. So basically you are moving down, down, and down. So what is happening, the material removal will be there. So material removal will be there, and here due to this what is happening, there is an electrolyte, so material will be removed, and material will be, after removal, it will be means like here, है ना, वो मटेरियल रिमूव होकर के वो नीचे रह जाएगा. So that is the thing. So material will be here in this case. Now due to this flow of this electrolyte, since you know that electrolyte is pumped out, right? So there is a pump, and with this help of the pump, electrolyte is flown in this entire process. So what is happening here, the electrolyte has some velocity, right? So due to this velocity, this entire debris, right? So this is known as debris. मतलब क्या, आफ्टर मशीनिंग जो पाउडर्ड फॉर्म होगा, जो मटेरियल रिमूव हुआ ना, तो मटेरियल हैज समथिंग, मटेरियल हैज रिमूव्ड, so that material is actually flown out, right? So suppose after that what is happening, so basically whatever the electrolyte is here, that electrolyte is flowing like this, right? And they are flowing, and they are again stored in the electrolyte tank. Fine. So see here, this is the electrolyte tank, and in this, some of the debris was there. So debris will be collected in the here. Fine. So these are the debris. These are the small particles are the debris. ठीक है. So this is all about the ECM process, right? So if you have not understood this ECM process, not very good, in a very good way, don't worry about it. I'm again explaining you in a very effective way. Try to understand here. So basically what we have seen these things, that there is a variation in the current density. Fine. So there is a variation in the current density, and this will result in the work taking the electrode shapes. फाइन. तो क्या होता है कि आपका करंट डेंसिटी में वेरिएशन होता है. नाउ व्हाट इज द करंट डेंसिटी? बेसिकली आई विल बी एक्सप्लेनिंग दीज थिंग्स, है ना. तो एक करंट डेंसिटी होता है, जिसके कारण क्या होता है, आपका जो वर्क जो होता है ना, उसमें डिफरेंट डिफरेंट शेप्स आता है. नाउ ट्राई टू अंडरस्टैंड हियर. बेसिकली दिस इज योर टूल. सपोज दिस इज योर टूल. फाइन, दिस इज योर टूल, and this is your workpiece. Clear? So earlier workpiece is flat. Now you want to make these kind of profile, these kind of cavity in the workpiece. So what you will be doing? So there is a electrolyte that will be flowing here. Now when you will be moving down, this tool, then these kind of cavities will be, you can see here, and hence the machining is done, and hence this is the machined surface, right? So hence in these way you are actually getting the machining done. Fine. Try to understand with this figure only. So let us assume this is your tool and this is your workpiece. Clear? So you can see here this tool has some complicated shapes are there. If it is not visible, don't worry. So see here, this is a workpiece, this is your workpiece, and there is a profile on the tool which you can see here. These kind of profile you want to replicate on the workpiece. फाइन. रेप्लिकेट मतलब क्या? जो टूल का प्रोफाइल है, वही प्रोफाइल आप वर्कपीस में बनाना चाहते हैं. तो बेसिकली क्या होता है ना, कि अगर हमें सपोज करें कि वर्कपीस में कुछ अलग तरीके की प्रोफाइल बनानी है, तो मैं सेम प्रोफाइल का जो वर्कपीस में जो प्रोफाइल मुझे बनाना है, जो कैविटी बनाना है या जो भी चीज बनाना है, मैं उसी चीज का टूल में वही चीज उसमें दे दूंगा. तो टूल का जो शेप होगा ना, वही शेप रेप्लिकेट हो जाएगा हमारा workpiece में. Now try to understand here. So uh, this is your tool. Fine. So this is your tool. Now this is your workpiece. So what is happening? This tool is moving in the downward direction. Correct. This tool is moving in your downward direction, and basically this entire thing is filled with the electrolyte. Yeah. So this is everything is filled with the electrolyte. Right. Now try to understand here what is happening, that you are giving a constant feed with that servo mechanism that I have explained you. So you are giving a constant feed, and you can see the material is removed. Material removal rate is going on. That is, the material is removed from here. You can see the very small particles are getting out, right? So this is the basically material removal is taking place. Now again you are moving down. So again the very fine cavity is getting here. That is the same thing. That is the beauty of the electrochemical machining processes, that whatever the shape features of the tool will be having, that exact thing would be replicated in the on the workpiece. Again it is moving down in downward direction. Definitely the very clear profile that we are going to get in the workpiece. Fine. So this is what is we are going to get. Now again, अगर मैं थोड़ा सा और उसको बढ़ाऊं, तो आप यहाँ पे देख पा रहे होंगे कि you have got a very nice and clean profile, right? This is what you have got. ठीक है. अभी आप सोच लें, ये सब चीजें जो है ना, कन्वेंशनल मशीनिंग में आपको नहीं मिलेगी, है ना. इस तरह की चीजें आपको कन्वेंशनल मशीनिंग में नहीं मिलेगी. इट इज वेरी मच हार्ड टू मेक दीज काइंड ऑफ थिंग्स. फाइन. So what you can understand from here, see what beautiful cavities that has been formed on the workpiece due to these kind of tools. है ना, समझ में आ रहा है? सो फॉर टू मेक अ वेरी मच प्रिसाइज थिंग, है ना, यू कैन सी हियर दैट द basically the principle is ion dissolution, right? So what is actually happening, whatever the ion is there, है ना, जो ions जो है ना वो सोल्यूट कर जा रहा है, वो मिल जा रहा है। तो उसके कारण यहाँ पे क्या हो रहा है, आप यहाँ पे देखें कि दिस इज एक्चुअली हैपनिंग इन द एटॉमिक लेवल, this is actually happening on the atomic level. So what is happening, the small atom particles is getting out, है ना, तो छोटा छोटा पार्टिकल्स जब बाहर आ रहा है तो उसके कारण क्या हो रहा है, हमारा सरफेस फिनिश बहुत ही अच्छा हो रहा है, ठीक है। So let us take. So I hope you have understood these things. So let us try to understand the electrochemical process. Whatever I have explained you in the throughout the slides, just I want to document these things so that that will be helpful for your making the notes. Fine. So what I have told you, that electrochemical machining is a reverse of electroplating. So I hope now you are in a position to understand that what exactly is the electroplating and why it is known as why the ECM process is known as reverse of the electroplating. Now see here, the basically the workpiece is made anode. We have seen, right? Basically the workpiece is made anode. So basically we have seen that workpiece is made anode. See here, this is the anode, isn't it? And tool is what? Tool is cathode, है ना? यही तो हमने देखा था. So basically, the two workpiece is made anode and which is placed in close proximity to an electrode, which is known as cathode. At a very high amperage, direct current is passed between them through electrolyte such as salt water flowing in the anode cathode gap. See here what is being told here. I have explained it also, but again try to understand. This is a tool and this is a workpiece. Fine, this is a workpiece. So basically after reaching at some distance, fine, suppose this is a distance, that is the minimum gap is there, fine. So this, after reaching to this gap, what is happening, the current is passed, fine, a current is passed. So basically when you are passing this current, basically when you are passing this current, so this process, first of all try to understand that what is the meaning of this process. So basically you are giving like 20 to 50 volt of voltage you are giving, and the current you are giving a very high amount, right? So basically this is a low voltage and high current process. So basically what you are doing here, this is a tool, this is a tool, and this is a workpiece. So what is happening, when they have attended a minimum gap, there will be a flow of electric current, clear? So due to this flowing of electric current, what will be happening, the same thing, just think about the electroplating, है ना, electroplating केस में समझिए तो क्या होगा, यहाँ से जस्ट यहाँ से आपका पार्टिकल्स जो होंगे, एटॉमिक पार्टिकल्स जो होंगे, वो आपका निकलना स्टार्ट कर जाएंगे। तो यहाँ पर जो एटम्स जो होंगे, छोटे छोटे एटम्स, वो यहाँ पर क्लियर होना स्टार्ट करेंगे और इस तरह से हमारा यहाँ पर मटेरियल रिमूव होगा। अच्छा, यहाँ पर जो इलेक्ट्रोलाइट यूज करते हैं, I have told you that these electrolytes, basically in this we use the salt water as a electrolyte. Now see here, now see here, basically the metal is removed by the metal is removed, the metal is removed by the anodic dissolution. Now what is the meaning of anodic dissolution, है ना, हमने समझा है कि एनोड में जो है, यहाँ पे देखें, see here, what is the material is removed by the anodic dissolution and is carried away in the form of hydroxide in the electrolyte. See here, let me tell you what is the anode and the cathode. See in this figure. So basically what is happening, anodic dissolution is there. What is the meaning of anodic dissolution? So this is your workpiece, isn't it? And this workpiece is connected with the positive terminal. So if the workpiece will be connected with the positive terminal, so definitely that is anode. Now the particles, the atomic particles at the anode will be dissoluted, fine. So that is known as एनोडिक डिसोल्यूशन, मतलब एनोड के ऊपर से मटेरियल जो है धीरे 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 एटॉमिक लेवल में रिमूव हो रहा है, राइट? दैट इज व्हाट इज द मीनिंग, दैट इज व्हाट इज द मीनिंग. So next thing, that MRR in ECM depends on the atomic weight of the material. What is the meaning here? Suppose that if the material, if that material is the copper, so for that MRR will be different. Suppose the material is like nickel, that material removal rate will be different. That is the MRR1 and MRR2. Why this is different? You will be understanding this because basically the principle behind this electrochemical process is based upon the Faraday's law. Based on the Faraday's law. Fine. So let me tell you about it. So basically the principle of the ECM process is based on the Faraday's law. Fine. And what is the Faraday's law? We are going to talk in a just a brief after some of the time. So basically in this I have told you what I have told you, that in ECM process we give a very little amount of voltage, fine, and a very high amount of current, so that's why I have told you that this process is known as low voltage high current. Clear? Now now see here. So basically the tool to work gap, so whatever I have told you, that gap will be there. This is a tool and this is a workpiece, fine, and there is a gap between them, isn't it? This gap we have discussed. So the tool to work gap needs to be maintained at a very small value of zero point 0.1 to be 0.25 mm, and a servo drive is provided on the tool axis for this purposes. So I hope you have understood these things, because I have told you there is a servo mechanism which is associated with the tool. So what is happening due to this servo mechanism? This tool will be getting the feed, continuous feed, and what should be the optimum distance between the workpiece and the tool, that is actually totally controlled by the servo motors. Fine. And the value of what? So the distance, the gap should be 0.1 to 0.25 mm. It should be like it is a range, right? It is a range. Don't get like in a very hard and fast thing that it should be zero point 0.1 or it should be 0.25. It should be in between any of the values. Now see here. So these are the most important things, right? So basically I have explained these things, that electrolyte needs to be pumped through this gap at a very high pressure ranging, है ना? हम जानते हैं कि बहुत हाई प्रेशर से हम इलेक्ट्रोलाइट को फ्लो करवा रहे हैं. वो पंप अरेंजमेंट याद है? That is the pump arrangement we have done. With the help of the pump we are just sucking this the electrolyte, and just electrolyte is flowed with a very high pressure from that tool, है ना? उस टूल के अंदर से वो बहुत हाई प्रेशर से निकल रहा था. Okay, so I hope these things are clear to you. Now see here in the ECM we have seen that these are the just materials that that is only for you only. That is I have explained you. Metal debris are there, है ना? वो याद करें आप, वहां पर वो प्रोसेस पे चले जाएं, है ना? Go back into that process. So basically what is happening after the machining, that is, this is a debris, fine. This is a debris. This part is the debris. Whatever the small after the machining, small particles are left over, so that left particles are known as debris, right? And that debris will be flow out again, and it is moving into this electrolyte tank. Fine, this electrolyte tank. और उस electrolyte tank में क्या होगा? वो debris जाके वहां पर collect हो जाएगा, है ना? और फिर से क्या होगा? फिर से यहाँ पर एक फिल्टर आप लगा देंगे, और उस फिल्टर से क्या होगा? इलेक्ट्रोलाइट फिर से फिल्टर हो जाएगा, और फिर से उसी इलेक्ट्रोलाइट को आप क्या करेंगे? पंप करेंगे, है ना? एंड दिस प्रोसेस विल बी अगेन रोटेटिंग. फिर से ये चलते जाएगा, चलते जाएगा, चलते जाएगा, चलते जाएगा. समझ में आ रहा है? दिस इज अ कंटिन्यूअस प्रोसेस, फाइन. This will be repeated until and unless you have not got your profile of interest. Now see here, we have seen that this is a tool, है ना? हमने देखा था कि टूल है. अभी ये टूल क्या हो सकता है? सपोज द टूल मे बी ऑफ कॉपर, मे बी ऑफ ब्रास, और अ ब्रोंज, और द अल्यूमिनियम, और ऑफ स्टेनलेस स्टील, एनीथिंग लाइक दैट, है ना? टूल जो होगा वो कुछ भी हो सकता है, बट इट शुड हैव अ ग्रेट प्रॉपर्टीज. What are the properties? The properties of the tool material should be high electrical and thermal conductivity. What is the meaning of high electrical and thermal conductivity? Suppose that this is a tool material, so it should be able to conduct conduct thermally and electrically, है ना। थर्मली मतलब क्या, अगर सपोज करें कि इसके ऊपर टेम्परेचर राइज करेगा, अगर ये टेम्परेचर राइज कर रहा है तो ये टेम्परेचर को बाहर निकाल दे। सो अगर उसका ये प्रॉपर्टी होगा कि वट एवर द टेम्परेचर्स आर एक्चुअली रेजिंग in this tool, so that is coming out. So if that is the coming out, so definitely it is actually maintaining its temperature, है ना। ये मेंटेन करेगा अपना टेम्परेचर को, और फॉर दैट मशीनिंग जो होगा अच्छा होगा, और मशीनिंग के कारण इसका क्या होगा, लॉन्गेविटी भी बढ़ेगा, क्योंकि ये वेरी हाई थर्मल कंडक्टिविटी का है मटेरियल। और इलेक्ट्रिकल कंडक्टिविटी का है तो मतलब, so if it is of having a very high electrical conductivity, definitely current will flow in a very large amount, isn't it? और हमने देखा था कि करंट फ्लो करने से ही तो हमारा रिवर्स इलेक्ट्रोप्लेटिंग का केस हो रहा है ना। सो इजी मशीनेबिलिटी होना चाहिए उसका, एज वेल एज हाई कोरोसिव रेसिस्टेंस शुड बी देयर, मींस लाइक कोरोसिव रेसिस्टेंस होना चाहिए, है ना। कोरोजन ना हो जाए। क्यों कोरोजन ना हो जाए? क्योंकि अगर आप ध्यान दें तो जनरली आप जो इलेक्ट्रोलाइट यूज करते हैं ना, जनरली जो आप इलेक्ट्रोलाइट यूज करते हैं, दैट इलेक्ट्रोलाइट इज व्हाट, NaCl, that is sodium chloride. So basically this is a little bit corrosive in nature. For that टूल जो होता है हमारा वो corrosive resistance होना चाहिए। Now see here, what is the advantages we are going to get from this EDM process, from this ECM process? Fine. So basically the complex three-dimensional surfaces we can make, and that too very much accurately, ठीक है। गुड फॉर लो मशीनेबिलिटी और कॉम्प्लिकेटेड शेप्स। सो सी हियर वी हैव सीन दैट, है ना, ये जो कुछ इस तरह का कॉम्प्लिकेटेड शेप्स अगर आप बनाना चाहें, सपोज दिस इज सो मच ऑफ कॉम्प्लिकेटेड शेप, है ना, वेरी मच कॉम्प्लिकेटेड शेप। If you want to make some complicated shapes like that, definitely you can go for this process. And one more thing that we have seen, since there is a this process is happening on the atomic level, so what we can conclude from here, surface roughness, so surface finish will be high, so surface finish will be excellent, surface finish will be excellent surface finish हमें इसमें मिलेगा। Fine. Now, next thing is the ECM leads to the atomic level dissolution. That's what I have told you. Because since this is in ECM, atomic level dissolution is happening, then the surface finish is excellent. Clear that we are getting the surface finish which is of around 0.2 to 0.6 micron, है ना। बहुत ही कम आपका मतलब surface roughness हो रहा है, तो जितना कम surface roughness होगा उतना अच्छा आपका surface finish होगा, है ना, with almost stress free machined surface without any thermal damage. Fine. Now the tool wear is practically nil. Now what is the tool wear? Try to understand. अभी देखिए, जब आप मशीनिंग कर रहे हैं ना, तो ये तो टूल हो गया आपका और ये वर्क पीस हो गया। अभी सपोज करें कि जब आपका, क्या देखें, ये सपोज करें, लेट मी ड्रॉ हियर ऑल्सो, सपोज करें कि ये आपका टूल हो गया एंड दिस इज योर वर्क पीस, this is your workpiece. Now what you have seen that electrons is actually flowing, electron is actually flowing, it is bombarding onto the workpiece, and the material is removed. Now the material is removed here, definitely material is removed from here, but what is happening, since there is a no contact is there, है ना। एक चीज याद रखें, अनकन्वेंशनल मशीनिंग में टूल और वर्कपीस के बीच में कोई कांटेक्ट नहीं होगा, तो कांटेक्ट नहीं होगा तो डेफिनेटली क्या होगा, आप टूल वेयर क्या होगा, टूल वेयर जीरो होगा, है ना। बट व्हाट इज हैपनिंग प्रैक्टिकली, जो हम देखें तो प्रैक्टिकली इस केस में टूल वेयर ना के बराबर होता है, बहुत ही बहुत कम होता है, एंड दैट इज नोन एज नील। फाइन। सो विच रिजल्ट्स इन अ लार्ज नंबर ऑफ कंपोनेंट्स प्रोड्यूस्ड पर टूल। तो इसका मतलब क्या, एक ही अगर मान लीजिए कि टूल जो है हमारा कम टूल वियर होगा, मतलब टूल का वियर, है ना, टूल का वियर कम होगा, मतलब दैट इज द टूल वियर। सो इफ टूल वियर will be less, then definitely from that single tool we can manufacture a lot of product, है ना, बहुत सारा चीज कर सकते हैं। MRR is highest. So in the earlier class, means like in the introductory lecture, I have explained you That MRR is going to be high for the ECM process, right? That is the around 1600, that is something around 10 to the power 4 mm cube per minute, कुछ इस तरह के रेंज में होता है among all the non-traditional machining processes comparable with the conventional machining. Okay, I have explained these things in the introductory lectures itself. Now what are the disadvantages? Basically, different, each and everything will be having some advantage, and definitely it is having some disadvantage. So disadvantage is that use of corrosive media, that is electrolytes that you are using, that is the NaCl है ना, NaCl. So NaCl में क्या problem हो रहा है? So definitely this electrolyte makes it difficult to handle, है ना. This electrolyte के कारण corrosive problem हो रहा है, और corrosive की problem जब हो जाती तो machining करने में थोड़ा problem होता है. Now, sharp interior edges and the corners, that is something around 0.2 mm radius, are difficult to produce, है ना. अगर आपको बहुत ही sharp radius का, suppose करें ये radius क्या है, suppose the radius is given as 0.2 mm, so less than 0.1, suppose if you want to make the radius of 0.1 mm, इतना fine अगर आपको बनाना है तो उस तरह का complicated चीज थोड़ा सा नहीं बन पाता है. Also, expensive machines are there, machine बहुत ही expensive होता है. एंड मोस्ट इंपॉर्टेंट डिसएडवांटेज अगर मैं कहूं आपको, जो आपको दिमाग में हमेशा याद रखना है, दैट इज व्हाट, नॉट एप्लीकेबल फॉर इलेक्ट्रिकली नॉन कंडक्टिव मटेरियल. सपोज दैट इफ आई सपोज दिस इज व्हाट, suppose this is the mouse, fine, this is the mouse, so you can understand that this is what this is. Can you say that this is a conductive or non-conductive? Definitely it is a non-conductive material, क्योंकि ये electricity तो conduct करेगा नहीं, है ना. So that is the problem. So definitely it can machine only that kind of workpiece that is actually electrically conductive, है ना. क्योंकि इलेक्ट्रिक करंट जो पास हम कराते हैं, अगर वो कंडक्ट करेगा तभी तो मशीनिंग होगा ना. So that is the main disadvantage, that the material should be of conductive in nature, and this is hence for the electrically non-conductive material it is not applicable. High specific energy consumption are there, ठीक है, बहुत ही energy ज़्यादा consume होता है इस process में, और fatigue strength is lower. Where we are applying these things, कहाँ पे हम basically ECM process का use करते हैं? So basically we are using these processes for understand any electrically conductive work material. अगर हमें कोई भी electrically conductive work material मिल जाए तो definitely we are going to use this process आंख बंद करके, fine, irrespective of their hardness, strength, or the even the thermal properties, है ना. Next thing is what, the machining surface can be situated at any inaccessible parts. नेक्स्ट इज शेप एप्लीकेशन. सी शेप एप्लीकेशंस क्या होगा, शेप आप ब्लाइंड कॉम्प्लेक्स कैविटीज बना सकते हैं, कर्व्ड सरफेस बना सकते हैं, थ्रू कटिंग कर सकते हैं, और बहुत ही ज्यादा बड़ा आप कैविटी भी बना सकते हैं. इट इज यूज्ड फॉर मशीनिंग ऑफ गैस टर्बाइन ब्लेड्स, है ना. इन द गैस टर्बाइन ब्लेड्स you can understand a very complicated shapes are there, complicated shapes are there. And for that kind of thing, what is happening, the gas turbine blades are made with the ECM process, die sinking, है ना, die sinking, profile and contouring, है ना. प्रोफाइलिंग अगर बनाए, कोई कोई कॉम्प्लिकेटेड प्रोफाइल आपका हो, या फिर कॉन्टूरिंग कर रहे हैं, वो कॉन्टूरिंग आप बना रहे हैं. प्रोफाइलिंग मतलब आप समझ रहे हैं ना, वो आपका कॉम्प्लिकेटेड प्रोफाइल मैंने जो आपको दिखाया था, दैट इज द सेम फिगर. ट्राई टू अंडरस्टैंड दैट कॉम्प्लिकेटेड प्रोफाइल, हाउ द कॉम्प्लिकेटेड प्रोफाइल कैन बी मेड विद दिस. Grinding you can do for the drilling purposes, you can use for the micro machining. What is the meaning of micro machining? Suppose that if you want to make a hole of, suppose the of 1 micron, of 1 micron, suppose you want to make a hole of 1 micron, so you can understand कि होल ही इतना छोटा है, लेकिन उतना छोटा होल भी आप बना सकते हैं माइक्रो मशीनिंग में ईसीएम करके. तो उसको क्या बोलते हैं, electrochemical micro machining, that is known as ECMM, electrochemical micro machining, fine, उसको बोलते हैं electrochemical micro machining. So I hope you are understanding these things fine. So I have told you that, so I have told you that this process is based on the Faraday's laws, fine, this process is based on the Faraday's law. So let me write it here, that the principle, right? That is the principle. So basically the principle on which this ECM process is based on, that is the Faraday's law. Faraday's law of electrolysis. Faraday's law of electrolysis. What exactly is the meaning of Faraday law of electrolysis? See here. So the Faraday law of electrolysis states that mass of material removed is directly proportional to the flow of charge within the electrolyte. What is the meaning? See here. The meaning says that mass of material removed. That means suppose the you are removing the m mass. Clear? m suppose करें कि आप m mass of material remove कर रहे हैं. So the mass of material removed is directly proportional to the flow of charge within the with the electrolyte. मतलब कि electrolyte में जितना charge flow कर रहा है ना उसके proportional होगा mass जितना आप remove कर रहे हैं. That means m is proportional to what? Q. That is q is what? Charge. And m is what? Mass of material removed. Clear? Now see here, we have seen from our prior knowledge that what is q is equal to what? Q is equal to I into T. Where what is this I? This I is the current and T is the time. है ना? सपोज मतलब क्या समझे आप यहाँ से? सपोज करें कि आप करंट पास करा रहे हैं कुछ टाइम के लिए, तो उस पीरियड में आपका चार्ज फ्लो करेगा. दैट इज द मीनिंग Q is equal to IT. Now, so I can replace this Q with the IT. So I can write here that M is proportional to I into T, where I is the current and T is the time. Clear? Now see here, we also know one most important thing, है ना? अब हम एक और चीज जानते हैं कि अगर मैं ये प्रोपोर्शनलिटी साइन जो है ना, अगर मैं इस प्रोपोर्शनलिटी साइन को रिमूव करूं, इफ आई वांट टू रिमूव द प्रोपोर्शनलिटी साइन, then there would be a constant that is coming in the picture, that is Z I T. Now what is this Z? What is this Z? What is this Z? So basically this Z, this Z is nothing but gram equivalent weight of material by Faraday's constant. Faraday's constant. Now try to understand. I have written that this Z is equal to gram equivalent weight of material. What is the gram equivalent weight of material? And this is divided by the Faraday's constant. So first of all, I just want to let you know what is the Faraday's constant. So basically this is a Faraday constant which has been given by the Faraday sir. Okay, and what is the value of that? That is actually 96500 coulomb per mole. Clear? So what is this gram equivalent weight of material? So try to understand here. This gram equivalent weight of material is gram equivalent weight of material. Right, so this gram equivalent weight of material, एक material का gram equivalent कैसे निकलेगा? वो निकलेगा आपका A by V. What is the A? Atomic weight of material by the valency. See here. So basically the gram weight of material is equal to atomic weight of material by valency. What is this atomic weight of material? So basically this atomic weight of material is denoted by A, and this valency. So वैलेंसी मतलब क्या, किसी भी मटेरियल का वैलेंसी कितना होगा, है ना। सपोज करिए वो कॉपर का बना है, तो कॉपर का बना है तो उस कॉपर की वैलेंसी क्या होगी, राइट, दैट इज द थिंग। So this is denoted by P. Clear? So what I can say here, that this is the gram weight of material. Clear? And we have seen that Z is, see here, this Z is gram equivalent weight of material by Faraday's constant. And what is this? What is this? Gram equivalent weight of material is denoted by E, and Faraday's constant is denoted by F. Clear? तो हम क्या कह सकते हैं कि M is nothing but E by F into IT, isn't it? Now I can again further go and replace this E with what? A by V. A by V. So M will be equal to A by V F into I into. Clear? So this is the mass that you are going to get here. Now don't worry about the units. What are the units? I'm going to again tell you. Don't worry. Just be patient here. Now see here. Now see here. What I can write from here, that M is equal to what we have seen, that A by VF into IT, to IT, where this M is, that is the mass is in gram. Mass is in gram. Clear? And this time is in seconds. This time is in seconds. I hope you are understanding these things. Clear? Now try to understand that what are the formulas that I have written. First thing that I have written, that M is equal to IT. So I have written that M is equal to ZIT, where Z is what? Z is nothing but E by F into IT. Again I have split this E into A by V, that is the A by VF. To just remember these formulas are very much important. And see the unit will be in gram, unit will be in the gram. So this is the formula nutshell. In the nutshell you can understand, this is the mass that is going to be removed during the electrochemical machining process. Fine. Now here comes the problem, that sir, I know the mass which is removed, isn't it? But what is mass removal rate? Means MRR. How we can find the MRR? So try to understand the basic physics behind it. What is the MRR? So try to understand the basic physics. You can understand how you can find the MR, that is the material removal rate. So what is this? What is this? How you can find the material removal rate? So basically this is in gram, isn't it? That is the mass is in the gram. Now if I will divide any mass with the time, मटेरियल रिमूवल अगर मैं निकालू, मटेरियल रिमूवल रेट निकालू, तो कितने समय में कितना मटेरियल रिमूव हो रहा है, यही तो होता है मतलब. सो व्हाट आई कैन राइट हियर, दैट if I want to find the material removal rate in gram per time, isn't it? Now what I should do here, I should do here that I know that EIT by F. See here, EIT by F. This is what? This is the mass, and this is in gram, isn't it? So I can write this is a mass which is in gram, which is in gram. So this is my mass. Now if I will divide this mass with the time, that is this is the time. So if I will divide, this is your time, है ना. ये अगर मैं इसको लिख दूं इधर, तो ये कुछ भी नहीं है, ये जो है आपका, ये आपका मास हो गया और ये आपका टाइम हो गया. Now if I will see here, this T and this T will get cancelled out. So what I can say, that MRR will be is equal to IE by F. IE by F, which is again written as, see here, I by F into E is what? A by V. See here, E is what? A by V, that is the atomic weight of material by the valency. If you are not understanding at this stress, don't worry. If when we are going to work out the problems, you will be getting understood each and every things how we are going to apply. Just try to understand here, these things are there. Don't worry about the application part. When we are going to apply these things, naturally we are going to understand each and everything. So this is the MRR. This is the MRR that we have got. And what is this unit? So I can write here that MRR is nothing but IA by FV. This is the unit is what? Gram per second. Gram per second. Fine, gram per second. Now there is a problem. Now there is a problem. Now see here, what is the thing that we have seen, that MRR is IA by FV. Now, if we want to find the MRR in mm cube per second, fine. Suppose if I want to find the MRR in cube per second, अगर इसकी यूनिट cube per second होगी तो मैं कैसे निकालूंगा? How I can find it? Try to see here what we know from the basic formula. What we have the understanding that we know that mass is nothing but it is equal to volume into density. Volume into density, isn't it? Now what is the volume? So see here, the if you would see from here that volume would be nothing but mass into density. Now see here, what is the unit of the volume? Can you tell me? See here, the unit of the volume will be cube, and the unit of the mass will be, see in this case we are assuming that it is in gram, and the density, so density is here. Now see here, from this what we can understand, that if we want the my MRR in the cube per second, so definitely we have to divide this volume with the time. That is, see here, if I am dividing this volume with the time, then definitely cube per second we are getting, Anna, isn't it? This is the thing. So what we can write here, that my MRR is nothing but the mass. See, this is the mass. So what is the mass that we have got? So mass we have got as this, that is the IE by F, IE by F, or the IA by FV. Let me write it here, that is IA by FV. Let this divide, let it divide by the density, let it divide by the density. Now when you are dividing this by density, you will be getting as this, C, this will be A by V. This is what? A by V. So you can write here I A by FV into rho, FV into rho. Now this is also written as what? I by F. A by V is what? This is E by rho. And the unit is what? Important thing is unit is in cube per second. Now see here, these all formulas what I have told you, that is the MRR, that is the MRR. So I have told you that MRR will be in IA by FV, that's unit will be gram per second, or MRR will be IE by F rho, IE by F rho, and its unit is what? Cube per second. So both the formulas, both the formulas are valid for a pure material. Now there is a, this is valid for a pure material. What is the meaning of pure material? That means that the entity of this whole material is made with a single material, right? That is, suppose if there is an alloy, so if you are taking the material, the work piece material is what? Suppose it is alloy. So suppose if it is alloy, and what you can understand, that alloy is made of one or two metals, right? Suppose करे कॉपर का बना है, जिंक का बना है, या निकल का बना है, तो तीन चार अगर मटेरियल बनता है, for that my MRR formula is going to be changed. What is the formula? Definitely we are going to see it, but this is the thing for the pure material. Fine. Now try to understand here. There is a concept there is a concept. So what we have seen that this is a tool. What we have seen that there is a tool, and this is your tool, and this is your workpiece. This is your workpiece. This is your workpiece. Now try to understand that. So this is the area, right? So this part is your area, right? This is your area, which is actually responsible for the machining processes. So can I say that this is your, oh, this is your tool area, right? Suppose this is the tool area. Fine, you have the tool area. Now this is your workpiece. This is your workpiece. This is your workpiece, and this is what, this is your tool area. Now in between what is happening when you have connected, this workpiece and this tool with the power supply, then what is happening, this is actually connected with the negative terminal, this is connected with the positive terminal. So what is happening, the current will be flowing, isn't it? So current will be flowing, but there is a gap, this is a gap, right? So this gap is known as, suppose this is denoted by the length L. So this is a gap, so there is a gap between the tool and the workpiece. So due to this gap, what is happening, there is an obstruction. So there is a obstruction in the path of the current, है ना? यहाँ पे करंट, जब यहाँ से करंट फ्लो कर रहा है, तो करंट फ्लो कर रहा है, यहाँ पे फ्लो करने के बाद करंट को पता चला, अरे बाबा यहाँ तो मेरे लिए जगह ही नहीं है. तो there is a resistance which is actually coming into the picture, and this is what is I am showing here. So this is the resistance वहाँ पे क्या, इस air gap के कारण resistance होगा, right? So suppose this is the resistance which is R. Clear? This is the resistance which is R. So this resistance R is denoted by the specific resistivity into L by the area of that machining. That is, it is also denoted by rho L by A. And these things you know from the basics only. So there is nothing so much which is hi-fi. I am going to explain it, but this is what is the basics things we have known. So in this context of ECM, there is another terminology that I want to define here, that is known as specific metal removal rate. removal rate so basically this specific metal removal rate is denoted by MRR specific, MRR small s. So what is this MRR small s? Basically this MRR small s, MRR specific, is denoted by whatever the MRR you are getting, that is divided by the current, so this is your specific MRR that is going to get. Now what is this specific MRR? So what is the MRR that you have got? This is the MRR, this is the MRR that you are getting. See here, that is IA by FV. So what is this IA? What is this A by V? This A by V can be written as E, है ना? This is your MRR. So can I write like that? IE by F. Let me write it here. IE by F. This is when divided by the current I. When this is divided by the current I, then what is happening? You will be getting as E by F. Now understand this specific MRR. What will be the unit? Its unit will be in the gram per second, right? Its unit will be in the gram per second. Basically, what you can understand, so here the MRR is what? MRR is in the gram per second, isn't it? Now if you want this MRR in mm cube per second, so definitely this is what, so IE by F rho would be there. You can write here IE by F rho, MRR by I, that will be IE by F rho divided by I, and definitely it is denoted by EF by rho. And this is your specific MRR. Clear? So I hope you understood this part. what is the specific material removal rate. Now you have heard the this terminologies that is known as current density, and just at the beginning of the lecture I have explained you that we have encountered a terminology that is known as current density. What is the meaning of current density? See here, what is the current density. So basically this current density which is denoted by J, so it is written as I by A. That is, suppose that the whatever the current is flowing in that area, है ना, किसी एक एरिया में, किसी एक पार्टिकुलर एरिया में कितना करंट फ्लो कर रहा है, how much amount of current is basically flowing on that area, that is known as current density. मतलब भैया करंट की डेंसिटी क्या है, मतलब करंट कितना डेंस फैला हुआ है, दैट इज द करंट डेंसिटी. क्लियर? I hope you are getting. So that is J is equal to I by A. Now if you could plug in these figures, right? So plug in these figures, so just remember these things, that this is current density is I by A. Now I have explained you that there is a servo mechanism is associated with the tool, fine, and due to this what is happening, the feed will be there, right? So there would be a electrode feed. Now due to this what is happening, the continuous feed will be happening, so there is a terminology that is known as electrode feed rate. So let me write it here, electrode feed rate. What is this electrode feed rate, my dear friend? See here, this electrode feed rate, see here, अभी देखिए आप इलेक्ट्रोड फीड रेट होता क्या है. यहां पर आप देखेंगे कि just a minute, you can understand that what is the MRR, EI by F rho, right? अगर अगर यहाँ पर आप, what is the unit, mm cube per second, right? Mm cube per second. Now what is the electrode feed rate? So basically you are giving some kind of this feed in the mm in some seconds or some time, fine, that is the electrode feed rate. मतलब कुछ आप एक्सेल डिस्प्लेसमेंट, कुछ आप वर्टिकल डिस्प्लेसमेंट कर रहे हैं एक particular time per, that is the feed rate. Now that is the feed rate. So if you can understand from here, the unit of MRR, the unit of MRR is mm cube per second. अगर मैं किसी तरह से इस MRR को एरिया से डिवाइड कर दूं, if I can divide it, then what will be the unit here? The unit will be mm per second, isn't it? Because this mm cube and this mm square, this will get cancelled out, and hence mm will be there, mm per second will be there. So what I am going to write here, the electrode feed rate will be nothing, so MRR, what is the MRR? So basically the MRR is EI by F rho, EI by F rho. And what is this area? This area will be divided by A. Clear? Divided by A. Now let me simplify this figure, that is the E F rho I by A, right? This is I by A. Now you can replace this I by A by the J. So this is what E F rho by. So what you can understand from here, that electrode feed rate is nothing but it is noted by MRR, which is what? Specific MRR. See here, this E by F rho. This E by F rho is what? Specific MRR to current density, into current density. Now you may be wondering, sir, why exactly you are telling me these formulas? That is the electrode feed rate formula is there. I have explained you. I have explained you the current density formula. I have explained you the specific material removal rate. So basically, why we are understanding in these things, in the gate question, gate, in the gate, in the gate, जनरली द क्वेश्चंस आर आस्क्ड फ्रॉम दीज फॉर्मूलाज ओनली. कभी कभी क्या करेगा, सपोज करें कि आपको प्रॉब्लम में करंट डेंसिटी दिया हुआ है, स्पेसिफिक मीटर रिमूवल रेट दिया हुआ है, ठीक है, अगर आपको ये सब चीजें दिया हुआ है तो डेफिनेटली फ्रॉम दोज अवेलेबल डेटा ऑल्सो यू कैन सॉल्व द प्रॉब्लम्स विदाउट एनी डाउट्स। ठीक है, तो इसलिए मैं आपको सारा चीज अच्छे तरीके से बता रहा हूँ। So I hope you are understanding these things, and definitely whenever you will be feeling that you are not understanding, you can reach out at my mail ID. Fine, and I will try my level best to clear your doubts. Fine. Now see here. So till now these things are clear to you. Electrode feed rate and what is are there. Now 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 see here. There is a We have seen that V is equal to I. It is voltage is equal to current into resistance. Fine, these things we have seen. Now अभी हमने देखा, क्या देखा कि अगर इस तरह का सर्किट होगा, इस तरह का प्रॉब्लम होगा, तो रेजिस्टेंस इज गिवन बाय व्हाट, रो एल बाय ए, इजंट इट? So I can write that current into rho L by A, that is L by A, right? This is the thing that we have seen. Now what is the V? What is the V? So basically V is the potential difference. Potential difference. What is the A? So A is the cross sectional area of machining. Cross sectional area of machining. ये cross sectional area. This is the cross sectional area. Fine. Now what is this? L. So I've explained this. L is the gap between the tool and the workpiece, isn't it? See here. This is the L. That is the gap between the tool and the workpiece. So what is the rho? Rho is the resistivity. Resistivity, which is in ohm per m. Ohm per m. So this is the formula, that is the voltage is equal to I into rho into L by A. Now can I write this like that? That is the V by rho into L. V by rho into L is equal to I by A. I by A. Now again, what is the I by A? What is the I by A? Is it current density? That is a J. Yes, that is a J. So I can write that current density is nothing but V by rho into L. This is also the again the another formula that is important while the calculation purposes are going. So till now we have seen the processes for the material removal rate for the pure substances, that is the pure material is there. When the material is pure, then we have what kind of material removal rate are there. Suppose let us find the material removal rate for alloys. Let us find the material removal rate for the alloys. Now what is happening with the alloys? So basically, suppose what we know that MRR is actually EI by F rho, it is mm cube per. This is valid for a pure metals. Fine. So this is valid for a pure metal. Pure. Now what is happening for the alloys? So basically, if you could see in this, the if the material is made of suppose of the two materials, fine, suppose the material 1 is there and material 2 is there, so it will be having a different density, that is the density 1 and density 2, isn't it? Agar material alag alag hoga तो density भी अलग अलग होंगी. So for that my density is not constant. Clear? Now also, what is this E? So E is what? A by V. Now if my material will be different, definitely the valency will be different, this atomic weight will be different, and suppose that it is in the A percent and it is in the B percent, then percentage wise the composition is also changing. So it is very complicated, figures are getting out. So we have to find the MRR in a very different way. Now try to understand here. I'm just writing here. So basically 1 by rho equivalent. So if you want to find the equivalent density, that is given by summation of xi by rho I. Okay, and let it be the 100 so that you can put it directly in the percentage form. Suppose what I mean to say from here, suppose that the first material is iron. Suppose this is an iron and this is the copper. Clear? Now if it is 50, suppose if it is 55% iron is there and 45% copper is there, so how you can find the equivalent density? So you know that density is rho 1, so rho I for the iron and rho copper for the copper. So you can directly substitute it here, that is 100 by rho equivalent is equal to xi by rho I, means what, x1 by rho 1 plus x2 by rho 2. What is the meaning of x1 and x2? X1 and x2 are the composition. Fine, composition, how much composition is there? So it is here 55%. Now you can put it here that 55% is what, my iron. So its density is rho 1. Suppose rho 1 is given to you and its density it is 45%, you can write 45 by rho 2. Now from here in this equation you will be knowing rho 1, you will be knowing rho 2. Only thing that is unknown to you will be the rho equivalent. So from here you can find the equivalent density. Clear? Now let us talk about the this E factor, right? This E, it is this E. Let us find this E. How you can calculate this E? So E will be calculated by 100 by E equivalent. This is equal to summation of xi into vi by ai. Clear? Now what is this x? This x we have seen that x is the proportion or percentage of material. Okay, now what is this vi? Vi is the valency of the material, है ना, कि material का valency कितना होगा? Vi is the valency of material, right? And ai is the atomic weight, atomic of material, atomic weight of material. Now you can write from here. So from here you can find the equivalent, E equivalent. Now you may be understanding, sir, how I can find it? Suppose that you have a cobalt. Suppose you have a cobalt, you have a nickel, and you have a chromium. Fine. Suppose by using these you have actually made a alloy, isn't it? Now suppose the atomic weight A is given to you, B is given to you, and percentage contribution, this is also given to you. Let me write it here so that these things will be clear to you. So suppose the atomic weight of the cobalt is given as 58.93, this is given as 58.71, and this is given as 51.99. What is the valency? Suppose its valency is given as 2, 2 and 6, and suppose that if this is an ly, if this is an ly, so suppose this is made by the cobalt, made by the nickel, this is made by the chromium. So suppose that this is what this is, its contribution is 18%, its contribution is 20%, its contribution is 62%, means एक एलवाई में 62% आपका निकल है, 20% आपका क्रोमियम है और 18% आपका कोबाल्ट है. That is what I am going to write here. That is going to be, this is 18%, this is going to be 62%, and this is going to be 20. Now based upon these you can put this in the formula and find the equivalent. How you can find it? 100 by E equivalent is equal to x1 v1 a1 plus x2 v2 a2 plus x3 v3 a3. Now what is x1? X1 is 18%, so put it here, 18 into 2 by, this is what, this is a1, this is 58.3 plus x2, this is 62, V2, this is going to be 2 pi 58.71, 58.71 plus x3. What is the x3? So x3 is the 20%, means chromium is in the 20%. 20% of the chromium. What is the valency? This valency is 6, and A3, that is atomic weight, is 51.99. So from here you can very easily calculate the E equivalent. The E equivalent. So what I want to tell from here, that by if the in the questions the problem is based on the Ly, so from here you can find the E equivalent. Clear? By using these kind of thing you can find the rho equivalent, right? And once the rho equivalent is known to you, E equivalent is known to you, so you can find the MRR for the Lys will be is equal to I equivalent by F into rho equivalent, and this will be in the mmq. Fine, this will be in the mmq per seconds. So I hope you have understood these things, and you don't have any problem in that. And one most in the nutshell, what you should remember is that ecm process has a excellent surface finish, है ना? ecm process में excellent surface finish होता है, excellent surface finish is there, as well as since it is happening, because it is happening due to the mechanism is atomic dissolutions, है ना? atomic dissolutions होता है, इसलिए आपका excellent surface finish मिलता है. ये चीज आप दिमाग में हमेशा रखें. And in the next class we are going to see some of the numericals what we are going to solve, and based upon that definitely we are going. So I hope you understood this topic. In the next class we are going to solve the numericals based upon the ecm process, whatever the concepts we have seen, and we are going to apply those concepts in the next class. So till then, if you have liked this video, if you have understood the concept, definitely like this video, as well as share this video in your friend circles. And if you're going for the plus subscription, use my code SIRVK, SIRVK, to get a 10% off. As well as you can always means like whenever you are going to enroll with my code SIRVK, then you're automatically enrolling in my personal guidance program. And if you have any doubt, definitely you can reach out to me. Till then, I'm just ending the session. Thank you so much.